Hello, everybody. We'll just wait for a few minutes for people join, and then we'll start the webinar. Just give me a little bit of time, maybe 5 minutes or so. Thank you. So maybe we just wait just 1 more minute. I still see some people logging in, and then we will start. Okay, so I think we are ready now. We might just kick off. Hello and welcome, everybody. Thank you so much for taking the time to be here with us today, this morning, afternoon, or evening, wherever you are. We are very grateful for the opportunity to share the insights on the new VCS methodology for rice projects with such an engaged audience. I am Carolina Lisboa. I work as a manager in the agriculture innovation team at Vera. And today we also have another 2 speakers with us on the line. And they are both, and both of them will hold most of the webinar presentation in the second part. First, we have Sami Osman, who is the CEO of Atoa Carbon. And then we also have Andrew Belcher, who is the Director of Carbon Program at Atoa Carbon. So before we dive into today's content, let's just quick go over a couple of housekeeping points and then what we can expect for the webinar today. For housekeeping points, the webinar will be recorded and available on Vera's website and the YouTube channel in about 24 hours after the webinar today. Please put your questions in the Q&A box you can see on the bottom of your screen. During the Q&A session, we kindly request you that you limit your questions to the topic of today's webinar. We want to ensure and address relevant and valuable information related to our discussions. We will have time at the end to respond to questions, but in the event that we run out of time to address all questions, please include your name when entering your questions for a follow-up and contact details. Or you can also follow up with your questions. You can send us an email. You can see my email on the bottom of this slide. In terms of our agenda for today's webinar, we will start with VCS program overview, which will be presented by myself, and then we move to the second part of the webinar with an overview of the VCS methodology for rice projects presented by our Atoa team. And then we close up with a Q&A session. So we'll kick things off now with the following. First, an overview of the VCS program. As you already know, the VCS program is the world's most widely used voluntary greenhouse gas program today. So the VCS is essentially comprised of different components, which is shown here in this slide. In the picture here on the right, you can see that at the core of the VCS program, there is an underlying VCS standard, which is a set of rules and requirements that all projects must conform to. Also, at the core of the VCS program, there is a set of accounting methodologies that essentially contains the procedures to quantify emissions reductions and removals for different activity types. So, for example, for agricultural projects like rice projects, focused on implementing improved management practices to reduce greenhouse gas emissions. Another component, independent auditing, where the third-party validation and verification bodies, or VVBs, complete a desk and field audit of a project. And then finally, we have the register system that tracks data on all registered projects, issuing verified carbon units. So now let's have a look at the VCS methodology requirements. We have in this document here, you see the picture of the front page of the VCS methodology requirements. This is a document that provides the requirements for methodologies, including tools and modules developed under the VCS program. In this document, it's basically setting out rules and requirements for each methodology component. For example, applicability conditions, project boundary, baseline scenarios, additionality assessment, leakage, quantification of greenhouse gas emission reductions and removals, and monitoring. Also, for a methodology to be approved under the VCS program, the methodology shall be assessed by a process that is set out in the VCS methodology development and review process. This new methodology for RISE projects follow the Vera-led pathway, where Vera releases a request for proposal. You might remember it was done in April last year for a methodology development. And then the methodology developers were selected. So we have Atoa Carbon, the line, who was the selected consultant to develop this new methodology for RISE projects. Then we started in November last year to draft this new methodology for RISE projects. We are now in a very early stage of this process, writing the methodology, and that's what we're going to present it here for you today. Is just the initial ideas and proposal for this methodology. We are essentially, if you look in this document, methodology development review process, we are on the step 2 with the concept note phase. Moving forward, we will have, when we have the draft of this methodology, these methodologies will undergo a public consultation period where all stakeholders, the public, can basically send their feedback on the proposed methodology. And then when this draft is finalized and the comments and feedbacks are approved by Vera, we also have an independent auditor, the VVB, who will also audit the methodology draft. And then finally, it will go through an internal approval process by Vera. This methodology will then provide a pathway for RISE projects to be developed under the Verified Carbon Standard program to ensure high quality VCUs, verified carbon units. So after this little background on the VCS program, I want to let you know that there is a lot of more information on the program itself that you can find by accessing our website. So please do reach out if you have questions. Now, I would like to get into the presentation of the overview of the new RISE methodology for RISE projects. With that, I will pass over to Atoa Carbon team Sam and Andrew, over to you.
Thank you, Carolina. Hi, everyone. It's Sammy Osman here from Atoa Carbon. So it's very happy to be here presenting to you on this. We're going to be handling the next part of this webinar, which will essentially be to go through an overview of the key issues that we're all have identified to date that we're looking at for this specific methodology. So I think we can go to the next slide, please.
Sorry, the slide is not moving my computer. Let me see. Just a moment. Thank you.
There we go. Excellent. Thank you. So right at the top here, we all know this is a new VCS methodology for rice projects. We've also got the VCS ID number there in case you want to engage with the Vera staff. You can quote that ID number and they should be able to find it. So this methodology here essentially will be based on the CDM methodology AMS 3AU, methane emission reductions for adjusted water management practice in rice cultivation. And from that starting position, there's going to be some significant updates. So in particular, we've got a few issues highlighted here. So we'll be ensuring that the quantification requirements are up to date, conservative, and reflect best practices. In particular, making sure that we move from the earlier IPCC requirements to the later 2019 refinements in particular. We're also making sure that this methodology is providing more robust monitoring requirements, making sure that we're absolutely do our best to ensure that the projects are robust with respect to monitoring. And then lastly, also to ensure that we have sufficient guidance to enable efficient project development. So one example there would be we're looking at additional guidance for stratification, which can help drive more efficiency in project development. Down the bottom here, we can show that we're also drawing key requirements and key guidance from existing methods and modules within the VCS program, in particular from VM42, which is the Vera methodology for improved agricultural land management. And some guidance is also coming from VMD53, which is a module attached to VM42, which gives us a lot of guidance with respect to biogeochemical modeling in particular. So I think we can move to the next slide, please. Great, thank you. So here, first of all, we'll go over some of the applicability conditions, which you typically see at the front of each methodology. So for this one, project activities must implement new cultivation practices that reduce GHG emissions, making sure that we have the additionality covered. They must meet regulatory surplus requirements, must have a farm-specific controlled irrigation in the baseline. Those of you familiar with AMS 3AU will recognize that we're saying here we're actually going to remove the need to show the entire region where the project is placed is dominated by controlled irrigation, but we will retain that project-specific requirement. Next, we'll also include training and agronomic guidance, and we're going to broaden that so it specifically covers any of the new practices that are adopted, and also specifically nitrogen usage. So even if nitrogen usage, efficiency gains aren't particularly targeted by the project, we'll make sure that each project provides agronomic guidance addressing nitrogen usage, as well as guidance specific to any of the unique practices that are implemented for that particular project. So for here, we may also look at additional guidance such as the qualifications and experience of the trainers and also the length of the training program that they're providing, just to make sure that we can ensure that the project developers, the farmers in particular, have sufficient experience to make sure that they're going to be able to achieve the yields that they're hoping for, so we can ensure food security in particular. And then down the bottom here, project activities may not decrease yield. We'll probably look at VM42 and be slightly more flexible, so not a complete ban. We'll most likely look at ensuring that any yield changes are de minimis. And we'll also look at impacts to wildlife, probably biodiversity a little more broadly, but definitely impacts to wildlife. One example here is that we have several methodologies that we've studied and we're drawing from, in particular in the US context, where there was concerns for migratory birds. So that's just an example of where we will look at potential impacts to biodiversity, and where appropriate, we'll offer some guidance and potentially some requirements specific to those. And those will be complemented by the existing VCS requirements for environmental harms. And lastly, standard in the VCS program, requirement not to clear native ecosystems within a certain time frame prior to starting the project. I think we can move to the next slide, please. Thank you. So first dot point here, a few newer concepts for inclusion. We're looking at a greenfields option. So by greenfields, we mean the introduction of rice cultivation, where rice was perhaps not cultivated on that specific farm immediately prior to the project. So we'll be exploring whether it's reasonable to include an option for new rice farms. Most likely, if we do, it'll be subject to agronomic guidance with respect to how suitable that particular area is for growing rice, and also looking at appropriate baseline assumptions, because that farm would not have historical baseline rice cultivation that we would draw from to set the baseline parameters. So we would be exploring the use of regional defaults for that. The next point, new guidance that previously accepting government subsidies for project activities is not an automatic barrier to entry. We've had several stakeholders to date that we've engaged with in this process that have pointed to existing government support programs and have, essentially been saying, look, these have not been as effective as we would hope. So we're still hoping to have VCS incentives to drive these types of practice adoption. So we're looking at providing guidance to specifically address that. But we should point you towards the VCM program rules and requirements. In particular, I want to draw your attention to the VCS methodology requirements, section 353. So that aims to, well, it provides a lot of detailed guidance with respect to no double counting. So essentially, that guidance tells us that we have to make sure, in this context, for instance, that these government subsidies were not specifically related to greenhouse gas emission reductions and that country's contributions to greenhouse gas emission reductions. If they were, then we can't offer a VCU incentive. That would be considered double counting. So we will explore this type of additional guidance, but it would have to be subject to those existing rules, in particular for double counting. And lastly, we'll be exploring removing the restriction on using new cultivars. And most likely, if we did that, we would require appropriate training for the farmers in the use of those cultivars. Again, just to make sure that we're not introducing any sort of threats to yield and food security in particular. However, we think it probably is appropriate to be a little bit more flexible there, whereas we saw the AMS3AU previous methodology be a little bit more restrictive with respect to introduction of new cultivars. We could move to the next slide, please. Excellent, thank you. So I won't read this line by line. There's quite a bit of content here, but this matches the typical layout that we see in the VCS methodologies. There's always going to be a table there which highlights all of the key sources and greenhouse gases that are addressed. So here we can see in the middle, methanogenesis. Methane is expected to be the largest source of greenhouse gas here. So that'll be the same. And then from there, we must account for several of these other gases if we expect the changes to be material. They won't always be material. So with respect to fuel usage, for example, it's quite possible that projects won't be making any significant changes with respect to diesel usage, for example. So we may or may not see projects have to account for the CO2 pool by way of example. We've flagged here a few sources that we're studying further, in particular nitrous oxide from soils. So we see a little bit of a TBD there. That is something that we're carefully studying throughout this development process. So it may be that that pool is included as a mandatory reporting pool, but that's subject to further study. Use of nitrogen fertilizers. Again, the S with the asterisk there, that indicates that at the very least, we will have to have an obligation where if there's any material increase in nitrous oxide emissions, which would be essentially due to material increases in uses of fertilizer, then that would be something that the project would need to report. And again, this is just to make sure that we're not crediting for CH4, which is the main focus, and ignoring any material changes to these other gases. And then a few other options there that we're going to be studying. Down the bottom, biomass burning. We will continue to study whether it's appropriate to include crediting for avoided burning of rice stubble. That's a practice which is still prevalent in many rice growing regions around the world. So we're exploring providing an accounting mechanism to issue credits for reduced biomass burning. So I think we can move to the next slide, please. Excellent, thank you. So for this methodology, the approach to additionality will essentially be a project method. So for those of you familiar with VM42, we'll essentially be bringing over the requirements from VM42. So first of all, there'll be a regulatory surplus study. So each project must demonstrate that in their particular region, there are no regulations that mandate the new practices that they're hoping to get credited for. That's pretty standard across the VCM program. And then we move to the project method, which essentially will be following the requirements in VM42. So that includes a barrier analysis where the project developer demonstrates what barriers were in place that prevented the projects from implementing those types of practices without the carbon incentive. And then secondly, a common practice assessment, where essentially the project will need to demonstrate the level of uptake of those particular activities that they're looking to incentivize throughout their project area. And the last point here, we have to tell you that we are also still exploring an activity method. So this option is under consideration, and so we're actively working towards developing an alternative solution here. And if we're successful, it quite possibly will be a dual option where you'll have either the project method or this alternative activity method. And so this will be essentially matching the activity method requirements in the VCS methodology requirements, where essentially we're undertaking the analysis, which is similar to the project method common practice assessment. We're studying whether we can collate enough data at this point to be able to identify specific practices. Maybe it's region specific, so AWD in one particular country, for instance. And if we're able to do that, we may create a positive list of combination of region and practice that we have sufficient data to show that those should be deemed as additional, and it would not require the project developer to then demonstrate for their project that that region and practice was included in their own common practice assessment. This may or may not be successful, and as a fallback, we will have the VM42 project method. So we know with clarity that that's what we're going to have, and then we'll continue exploring this second option. I think we can move to the next slide, please. Thank you. Okay, another busy slide, but I think this one's important, so we'll try to cover most of this. So in terms of quantification, at this point, we are planning to have three main options for quantification. And essentially, this would then defer to the project developer to be choosing the option that best suited their project. So first of all, we're looking at a biogeochemical modeling option. This would be for methane, nitrous oxide, and potentially also for soil organic carbon. We have extensive guidance in the VM42 methodology, as well as VMD53, with respect to how one must validate a model before being able to use it under VCS methodologies. So we have a lot of really good guidance that's been developed pretty recently in the VM42 and VMD53. So for the modeling option, we plan to draw on that existing set of requirements and guidance. However, as noted here, we are exploring potential changes from that starting position of the VM42 and the VMD53 guidance. And here's a couple of examples of some options which we are continuing to study. So we have to note that we have not undertaken this work, it's not completed. So the default would be that we would defer to the VMD53 and the VM42 modeling requirements. But here's a few that we're studying. So one is a de minimis exception to exclude SOC from SOC pool entirely. In other words, we're studying whether the series of eligible practice types that we anticipate for this method are likely to materially impact soil organic carbon or not. If not, then hopefully we can carve a safe exception to the requirements to model for SOC for this particular methodology. If we did that, we would study whether there are any prerequisites that would have to be demonstrated first. For example, if there are specific practice changes that we think actually might impact SOC materially, but everything else doesn't, then we might say, okay, as long as you don't do this one particular practice, then you can treat SOC as de minimis. We may also have to include a default deduction for SOC. For example, even if there's de minimis SOC changes expected and we want to exclude those to simplify the accounting, we may include a de minimis deduction for SOC just to be make sure we're conservative. Next, we're looking at sourcing SOC data from defaults rather than direct measurements. So those of you familiar with biogeochemical modeling know that typically there's a requirement to have direct measurements for soil used to spin up, calibrate, and validate the model. So we're exploring whether that's critical or whether as an alternative we could use default SOC and bulk density and other data to achieve that model spin up, calibration, and validation. And lastly, we're also exploring an option to create simplified modeling using fewer inputs. Those of you familiar with the rice carbon offerings in the United States will probably remember that an effort like this was undertaken for the California compliance system in particular. So the idea here would be instead of, let's say, 100 or more input parameters that are necessary, we would whittle that down to potentially, half a dozen, 5 or 6 that are most critical. And that way it would greatly simplify the modeling. So again, there's a few options here we're exploring to make more efficient modeling, more efficient use of this option, but those are not guaranteed. And so the default would be VM53, VM42 guidance. The second option we're exploring is direct measurements. Those of you familiar with AMS 3AU will know that there's already guidance in that methodology for this option. So we're going to be exploring that guidance and most likely making substantial updates to that guidance. So for methane, we're going to be creating an option where direct measurements will be possible. We're going to be exploring technologies other than chamber measurements. At this point, there's still a lot of work to be done, and quite possibly we will not have sufficient data to approve a whole list of different technologies. But we will be exploring whether it's possible to create a clear validation pathway for future emerging technologies that are not quite ready for us to include on some sort of a positive list at this point. We'll also be looking in particular at diurnal and seasonal greenhouse gas fluxes. Those of you familiar with direct measurements in field will know that, you know, potentially there could be some significant variability in terms of when these emissions are being put out on a particular field. So the AMS3AU guidance does not cover that. So there's an example of some additional guidance that we're carefully considering here. And lastly, stratification. So we touched on this before. We're looking to bring over the additional guidance from VM42 on stratification. We had a couple of stakeholders ask us about the stratification guidance in the existing methodologies, wondering if, you know, that they are as rigid as they might appear from first reading. And so what we're going to be addressing is making sure people are aware that we're going to be bringing over a little bit more flexible options that we see in VM42. So very robust guidance, but also greater flexibility to allow people to create options that are more suitable for their project. Lastly, default emission factors. So these are widely used in the previous projects that we saw in the VCS and also other systems. So we're going to be bringing those across from the AMS3AU, updated for the IPCC 2019 refinements. So those include defaults for methane, nitrous oxide, and CO2 from energy usage. Again, we mentioned that we might have a SOC deduction for a de minimis exception. We're also looking at the N2O correction factor. So that's something that we saw in the IPCC 2019 refinements. This is a very useful factor, which essentially focuses in on those irrigation changes that we're expecting as to be the key driver here in practice changes. So we do have that in the IPCC 2019 document that we'll bring across. And then down the bottom, just a list of specifics. So again, IPCC 2019 updates. We're also looking at a option for projects to develop their own emission factors using literature. And then lastly, we're also exploring the option for project developers to develop emission factors using biogeochemical modeling. And more recently, we actually got asked for another option, which is to explore the development of emission factors using direct measurements. So we're going to be exploring several of those options. At this point, it's not clear if we'll make it into the methodology, but we're certainly going to be exploring those closely. So I think we can move to the next slide. Excellent, thank you. So in terms of leakage, there are a couple of issues which we've identified already. So firstly, yield. Any sort of material significant reduction in yield must be accounted for. This is something we see in multiple methodologies, in particular VM42 section 843. So take a look at that. That's most likely what you'll see here in this new methodology. We've also flagged another issue, biomass. So for those projects that significantly change how biomass is used on farm, quite likely we'll bring across guidance from VM42 to address that. And then we have to flag that at this point, we're also considering leakage impacts with respect to a range of other issues that we've identified, which are not listed here. So we've got a whole series of different potential eligible project activities, and we're going to be carefully studying leakage with respect to each of those. So the final methodology may end up having further leakage requirements, which we haven't identified at this point. So I think we can move to the next slide. Excellent, thank you. So in terms of uncertainty, there's probably going to be more guidance in this method than we see in the previous method. So for the first quantification option, biogeochemical modeling, uncertainty analysis is going to be a critical requirement. So we're very likely to see the same guidance brought across from VMD 53 and VM42. For the direct measurement option, we're going to be assessing uncertainty with respect to the in situ direct measurements. We see some such guidance in existing methodologies. And then for the third option, default emission factors, we're going to be very carefully looking at the uncertainty work, in particular done by the IPCC themselves, and then drawing on other sources as well. Yeah, so essentially, most likely we're going to see more guidance with respect to uncertainty than in previous models. And then we're also going to be exploring additional guidance for the use of digital MRV technologies. So in particular, exploring options for quality assurance, quality control, and maybe also options to guidance to demonstrate the efficacy of digital monitoring tools. And that may or may not include requirements specific to uncertainty. I think we can move to the next slide. Excellent. Thank you. So monitoring, again, this is going to be a key area of focus. We saw a lot of attention on monitoring as a sort of a driver for this entire methodology development work. So this is certainly going to be an area of careful focus for our team and the VCS Vera team, sorry. So we're going to be mapping out all of the data requirements for this particular methodology. Those of you familiar with VCS broader work will know that there's a DMRV team at Vera, which is actively building out the next generation of digital architecture for the VCS system. So we will be fitting into that work. First of all, we'll be comprehensively mapping out every single data requirement for this project and feeding it into the VCS DMRV team, which will facilitate a more streamlined project development process. We'll be working with Vera's DMRV team to enable the use of digital data platform. And then we're going to be providing in the methodology itself guidance parameter by parameter, which is what you're all used to seeing in each methodology. So that'll be something that you see here as well. In terms of data hierarchy, that's a question that is always front of mind for project developers. How do we know which sources are appropriate for what? So we'll be bringing across as a starting position the data hierarchy guidance that we see in VM42, in particular box 1. And then we'll be looking at potentially giving additional guidance here specifically because we have a RICE context. We can maybe dig in a little bit more. We can give a little bit more discrete guidance. So in particular, looking at potentially extra guidance for time, date, and geostamp photos. Survey-based approach is appropriate. For these RICE systems, we expect the majority of projects to be dealing with very large aggregations of impoverished smallholder farmers. So something like a survey-based approach is most likely going to be critical. So we will make sure we give guidance so project developers know that we know to expect it and that is going to be appropriate. And then greater flexibility with respect to sources of data for the emission factors. And that's really just keeping this method in line with what we see in other VCS methodologies. So you're able to draw on a range of different sources. And then for remote sensing, we anticipate this to be critical for RICE projects. So most likely we will not see any mandatory requirements to use remote sensing, but we're already seeing how incredibly powerful and useful this technology can be. So we will be exploring whether it's reasonable and appropriate to offer additional guidance with respect to how to ensure data veracity. In other words, the data hasn't been manipulated from one source all the way through to the end. And then for transparency and security with respect to how to handle digital data. I think we can move to the next slide, and that's the end of this part of the presentation. So again, big thank you for joining us, and we look forward to engaging in the QA/QC and later. Thank you.
So thank you very much, Sunny, for the presentation. Yeah, with this last slide here of the presentation, I just want to give you an impression of the expected timeline for this methodology, for the development of this methodology. As you remember, we have started a review of the old CDM methodology, AMS 3AU. And that resulted in the inactivation of the methodology last year. It was, if I remember correct, about in March. And then right after that, we started an internal methodology scoping. And at that time, we also started interviewing key stakeholders working on this area. And then we decided then that we should definitely develop a new offer for rice projects under the VCS program. So we launched in Q3 2023 a request for proposals to select a consultant to develop this new rice methodology. That resulted in the selection of ATOA Cabo, the team that you heard just about 2 minutes ago. So we started them, work with them in November on the development of the methodology draft following the VCS methodology development process and review, which was presented during the presentations before. So moving forward now, we are now in the Q1 2024. We have started the draft. We are in the concept note phase. That will be followed by the public consultation, which we expected to start in the Q2 of this year. And then after that, we will have the VVB assessment planned for Q3. And then we hope to finalize and publish the new VCS rice methodology by the end of this year, sometime in Q4. So it is a very ambitious timeline, but so far everything is running out well. And we are very committed to deliver this product by the end of the year. So that's our plan. Moving forward now, I think we're gonna go to the Q&A session. If I may, I think I'm gonna just answer the first question here, which is about, let me just find it, now I lost it. We have someone in the audience, Jacob Penner. Sorry if I pronounced your name incorrectly. You say it's my understanding that the VM42 can already be used for rice projects. How will this methodology be different, and what's the reason why a project developer would use this new methodology instead of VM42? So that's correct. Currently, any project developer could use the VM42, but as you know, it's a very complex methodology, not really, it's not easy to handle for rice projects. And for example, one of the requirements of VM42 is the requirement for soil carbon measurements. And what we are trying for this new rice methodology, for example, is to have some rules and requirements for a project developer to monitor the soil organic carbon stocks, eventually without having to measure it. That's one example of the advantage of using this new rice methodology, and also because you're going to find specific guidelines helping a project developer to implement a project, for example, in terms of certifications, and also guidance for field measurements. So I hope I have answered your questions. If not, please send us an email that we can clarify further questions. So I think I will ask Andrew and Sunny if you want to answer any other questions.
Sure. I'll jump in. We've got a good question on farm-specific controlled irrigation. The question asks, would this allow eligibility in large-scale national irrigation systems, such as those in the Southeast Asia, where irrigation is not necessarily controlled at the level of a singular farm, but groups of farms together decide their irrigation schedule? I suspect yes will be the answer here. And what's key is that we're going from, a much simpler continuous flood to a system where they're able to remove the water from the field. So it's less critical that we understand exactly how that irrigation set up and who controls it. And really, we just need to see that the field itself is dried out. So assuming the irrigation system is capable of drying out, the particular field once or more than once, that should be sufficient. We may look at some sort of controls or extra guidance with respect to how efficient those systems are. For instance, if they're left dry for too long, it can be a risk for yield. So there may need to be some additional training or guidance with respect to those issues. But other than that, other than making sure we safely account for yield, then I suspect yes will be the answer to that.
Any other questions, Sammy? I see one here. It's regarding the biogeochemical modeling. Will biogeochemical modeling option allow for project developers to supply direct measurement data of methane emissions and N2O from the project area and control sites for model calibration? This would be specifically useful in the context of limited region-specific data sets. Yes, definitely. We are looking and evaluating this idea of using direct field data to work out with a biogeochemical model. That's one idea. And yes, there are very restricted access, limited region information concerning these two gases. We are not really sure at this point if we'll be able to collect the data, particularly for N2O, but definitely for methane emission CH4, there will be some guidance there to use biogeochemical model and field data for model calibration. So let me see.
Excellent.
If
I've flag one more, Carolina. Let's see. So there's a question on, can you give an example of direct measurement technology other than chamber measurements? So yes, definitely. But please do remember that we're not saying that this is going to be included, but we are exploring it further. So eddy covariance flux towers is an example of an alternative option that has been deployed certainly on research facilities and with some really good results. However, there are some complexities. For example, this is a tower that sits well above the field, so one has to look at potentially other sources of N2O or CH4 coming from cars driving past, for example. So it's a little bit more complex in terms of how do we model and determine the source of the CH4. But there's an example of an alternative technology which is certainly being used in the research field. And so we'll be exploring that as one example. And I think there are some other examples coming from oil and gas industry where there's laser-based meters, etc. So we are looking at a range of different options. But at this point, we can tell you with confidence, chamber measurements are going to be, we have sufficient guidance for that, but we do not yet have sufficient clarity on these other options. So we will try to include a validation pathway, or maybe we will not be able to include any such options, but we're certainly studying them.
Thank you, Sammy. I think question here. Are you open to accept emission data generating using instruments, sensors, other than traditional gas chamber methods for methodology draft? We have extensive discussions around this topic, allowing the use of other technologies or equipment to measure methane emissions, for example, from field. But we found out at this point that we need further studies on this regard to ensure that it's applicable to any project developed in a large scale. And also there is some issues concern of standard protocols for field measurements for this type of technologies, and which is still missing like a globally applicable protocols when adopting this technology in large scale. So answer your question in short, possibly for this methodology at this first version, we might not include those technologies, but we will keep having a look and following up the developments on this regard. So Sammy, any other question you would like to take?
No, let me keep looking though. Yeah, so we've got a few harder ones, probably best not to answer verbally, but I'm going to do it anyway. So we've got a few questions about the nexus with VM42. We've got one question which says, you know, we've already got a project in VM42, and we've got another one which talks about fallow periods. So we haven't explored this in detail yet, but we will probably try to make some recommendations to the VCS team and include guidance that helps people understand when do I use the RICE method and when do I alternatively use the VM42. And so we'll probably try to have specific guidance that helps you understand, okay, if it's a RICE only project, you have to use this. If it's a project that has several other crops in it, then maybe you use rice for this part and the other parts you have to use VM42, etc. So we haven't explored that yet, but that is something that we will be actively working on and try to provide some guidance to the VCS team. So hopefully by the time this method is finished, you will have a little bit more clarity with respect to when to use one versus the other.
Thank you, Sam, for clarifying that. So we have another question here from Regina. When can we expect rules and requirements for digital MRV, like using remote sensing? Yeah, I think Sam also touched upon this point on the end of the presentation. We are definitely very much trying to add the DMRV platform and made it available for RICE projects. And we also definitely will have to set out some rules and requirements for project developers to use remote sense applications for RICE project monitoring. And yeah, when we can expect, basically it's when the methodology is finalized and ready to be used. Let's say by the end of this year, we hope we can have be able to add the digital MRV for RICE projects, and yeah, and made it available using the Vera DMRV platform. So let me see if there is any other questions you would like to. Yeah, there's another question here. I think it's also concerned to the DMRV when it's ready. Yeah, everything run well. We hope again to have this option for project developer to use a DMRV by the end of this year for specifically for RICE projects and these new methodologies. Andrew or Sammy, any other question?
Yes, we've got a tricky question about yield. This question is saying, well, yield's always changing, so we do see projects where yield goes down a little bit. So again, we'll try to draw from the VM42 guidance with respect to yield, and in particular, sometimes yield declines are treated as leakage. So under that method, there is guidance to help us look at the regional yields. So in other words, if yield is going down for the region as a whole, then there's quite possibly some drivers there, such as climatic conditions, drought, or something like that, or pest conditions at the regional level. So if we see impacts like that, then in the VM42 method, we're able to sort of discount those and not treat that as something project specific that needs to be penalized. However, if there are significant yield declines just on the project itself and not elsewhere, then most likely we would have to account for that as a deduction through the leakage requirements. So there may or may not be impacts on the project accounting, depending on how significant the yield decline is, and then also whether those declines are shared by the neighboring farms.
So thank you, Sammy. I think I'm just going to answer one more question here, and then we can possibly close and follow up by email. There is a question here: how is Vera connected with IRRI methodologies, URI methodologies? I'm not sure what you mean by how Vera is connected with URI methodologies, but as far as I'm familiar with those methodologies, if they are complying with the new VCS rights methodology, I would see no objection to that. But again, remember that the project proposal should comply at the first place with the VCS rules and requirements and the new VCS rights methodologies. But I also want to say that we have a good line of communication with IRI Institute, and we definitely you'll be consulted with them also, and getting their input expert for the development of these new methodologies. So with that, I'm just going to check with Samuel Andrew if you want to say some final words. Otherwise, we just close the webinar for today.
Yeah, we've got one more question from Leslie, some good questions from Leslie, so thanks for that. This asking, what are the full set of activities that should be supported besides water management? So we gave out a few examples. We're going to have, with obviously AWD, dry seeding. We're also looking at avoided emissions from the burning of residues, potentially also for nitrogen use efficiency, maybe also for reductions in CO2 from energy usage. We're also exploring potentially including methanotroughs. A little bit of extra work is going to be needed there. And so essentially, hopefully this method would be practice neutral in the sense that similar to VM42, if it works, you can do it and hopefully you'll be able to detect a change. So we're actively exploring a range of different options. And if there's something specific you're hoping to get into, then I recommend reaching out to the VCS team and engaging, and we can help drive our research.
Yes, Sammy. So with that, I think we're gonna go to the end of this webinar. First, I want to thank you all again. Thank you all for your excellent questions, and I apologize to those questions and that we could not answer now, but please reach out to us, that we'll be happy to clarify your questions via email. You can see my email there in this last slide. And also, as a final reminder, I want to let you know that the webinar will be alive in 24 hours and available in our Vera website, as well as Vera YouTube channel. Thank you very much again, and talk to you and see all of you next time. Thank you.